welcome. So today we are going to learn about the distributive law. We're going to use the distributive law to expand simple expressions such as a outside of b plus c. We're also going to factorise by removing common factors. We're also then going to look at FOIL to expand a binomial product. So that's where we have, for example, a plus b times c plus d. So each of these, by meaning two, we've got two terms, two numbers. We're also going to look at some of our recognition expansions. So we have two. One is called the perfect square and the second is called the difference of two squares. So in our first example up the top, we've got x outside of x plus 5. So using the distributive law, what we're going to do is we're going to take our x, multiply our x times our x. That's going to give us x squared. We're then going to take our x, multiply it by our 5. So we're going to have a positive 5x. For our next question, we've got 2x. We're going to multiply that by 3x. So we have 2 times 3 is 6. X times x is x squared. Then we're going to multiply our 2x, multiplied by negative 6. So 2 times negative 6 is going to be negative 12, and then we just have a simple x. What about doing in reverse? What if we want to factorise? So we've got 6x plus 3. So in terms of our common factors, we've got 6 is 2 times 3 times x plus 3. So our common factor is our 3. We can bring our 3 up front, so dividing each term by 3. So if we were to divide 2 times 3 times x by 3, we're left with 2x. Dividing our 3 by 3, we're left with 1. A common error is where we're dividing and we actually end up with 0. But 3 divided by 3 is 1. In our second example, we've got 8x squared minus 2x. So in our 8x squared, we actually have our 8 can be divided into 4 times 2. Our x could be split into, or x squared could be split into 2 lots of x minus 2x. So now our 2x is our common factor. We could bring that out the front. And what's left is 4x minus 1. So in terms of expanding binomials, often we learn this process called FOIL. So F stands for our first, O is outside, I is inside, L is last. Essentially what we've got to do is take each term in the first expression and multiply it by each term in the second. Easiest way to make sure we're doing that is to use our pens and draw some lines, the same as with our regular expansion. So we're going to take our x, multiply it by x, that's our first. So we have x squared. And take our x, so our first, giving it outside, so our first times our last, x times 2 is 2x. Now we're going to take our inside, so our second term by our first, plus 5x, and then our last, so our 5 multiplied by our 2, so plus 10. Now the lines that I'm drawing are actually quite important. It's about making sure that we don't forget any term that we're expanding. At this point now we want to collect our like terms, so we have 1 x squared, we have a 2x or positive 2x and a positive 5x, which is going to give us 7x, and we have our 10. Next, a little bit more complicated, take our first term multiplied by our first term, so we're going to have 2x squared, our first term multiplied by our last term. So 2x times negative 2 is negative 4x. Our 7 times our x plus 7x. And then our 7 multiplied by our negative 2, giving us negative 14. Collect our like terms together again. So we have 2x squared minus 4 lots of x plus 7 lots of x gives us positive 3x minus 14. Next, we're going to look at an actual square. So we've got x plus 5, x plus 5, which is actually the same as saying x plus 5 squared. So let's look at what happens. X times x squared, x times 5, 5x, x times 5, 5x, 5 times 5, 25. Bringing it together, x squared, we actually end up with 2 lots of 5 squared, so 10x plus 25. So let's do this with our a and b. See if we can put our rule together. So we've got a plus b times a plus b. So a squared, ab. Now I know it's BA, but we always try and do things in alphabetical order just to make it look a little bit more easy to read. AB, b squared. So we've got a squared plus 2 lots of ab plus b squared. Let's bring it back to over here. So we've got our a squared, x squared, plus 2 lots of ab, so 5x plus 5 squared. What about if we had negatives here? What would actually change? Well, our x times x would still be x. Our x times negative 5 would now actually be negative 5x. Our negative 5 times x would be negative 5x. Our negative 5 times our 5 is actually still positive 25. So all that changes here is our negative 5 would become negative 10x. Positive here is a negative. So looking at our rule, if we've got a minus b times a minus b, it's still a squared is now minus, minus, minus. So the only thing that changes by this becoming a negative is the sign in front here. So what we can look at doing is with our rule is just condensing it down into one rule for both squares, where we say a plus or minus b squared is equal to a squared plus or minus 2ab plus b squared. Where if we've used a plus here, we have a plus. If we've used a minus, we have a minus. Okay, our last one, which is called our difference of two squares, and we'll see why it's called the difference of two squares in a second. So let's start with our actual algebraic form. If we've got a plus b times a minus b, we've got a times a, which is a squared, a times minus b, which is minus ab, we have positive b times a, which is positive ab, and then b times b, which is, sorry, positive b times negative b, which is negative b squared. When we collect our like terms, we're left with a squared minus b squared, because we have a positive ab and a negative ab. So bringing this into a question with some numbers, we're going to move down to x squared minus 5x plus 5x minus 25. Collecting our terms, x squared minus 25. If we tested our theory here, well, does a plus b, a minus b equals a squared minus b squared? So our a was x, our b was 5, so that should be x squared minus 5 squared, which was what we've gotten to. So, as I say, our expansion, a plus b, a minus b is a squared minus b squared. And the reason it's called the difference of two squares is we have two squares, a squared, b squared, and it is the difference of those two squares. Okie doke, so, in summary, we have looked at expansions. We have our rules of recognition. So our FOIL, how to expand. We have our perfect square, a plus or minus b squared is a plus or minus b times a plus or minus b, which is a squared plus or minus 2ab plus b squared. And our difference of two squares, a plus b, a minus b is a squared minus b squared.